Okay, so yesterday we reviewed conjugate pairs, and we talked about if A plus BI was there, A minus BI is there, always. Yes? But only when you started out with real numbers to begin with. And we went through that. So the reason why we need to know that is because you will get things like this. It will say find a fourth degree polynomial function with real coefficients that has -1, and 3i as zeros. So I have to go backwards, yes? Where did zeros come from?
Factors.
Factors. Where do factors come from? Polynomials, right? So we have to go backwards. So when we do this, we remember the fact that we have conjugate pairs occurring, yes? So if 3i is there, what is also there? -3i. So when we put those into factors, what are my factors? X plus 1, X plus 1. And then what do I do then? I multiply it out. So you multiply it out, and I'll multiply it out. We better get the same thing when we're done, yes? And when we are done, should we have any imaginary numbers involved? No. We should not have any imaginary numbers. I'm multiplying.
I see that, but it's like very confusing to me.
Really?
You know what else is confusing? Who else?
You can't figure out what I did?
What do you do?
You just line
Figure
it
it
up.
out.
I just lined it up, right?
Now, I get it now, but when you were doing it, it kind of confused me.
Oh. And I also multiplied by the trinomial, and I hate doing that. Anybody else? Like if I have a binomial and a trinomial, which one do you usually like to distribute? The binomial, and I didn't, and it bugged me.
You know what bugs me?
Okay, did you guys get x to the fourth plus 3x cubed plus 10x squared plus 18x plus 9? Okay, do I have a fourth degree? Yes. What if instead of fourth degree, what if they said fifth? What would I need to do with one of those factors?
Multiply it.
And again, right? Yeah. So I would add, I personally would add, actually the only one I could do is that one. I couldn't add the 3i because that would be 2 more factors instead of 1, correct? If I wanted 5, I just added another, I'll show you. I think the next one's like this. Oh no, this one's not. But I'm going to go back. If on a normal problem, this one would not be here. Got it?
Okay.
And it would say, make a fourth degree polynomial having those zeros. Okay? So if 3i is there, what's also there? -3i. So you would have plus or minus 3i. But then that would be -1 needs to be how many times? Twice. So if I said fifth degree, the -1 would have to be 3 times. But if they gave me another 0, I could choose between them. I just can't duplicate the imaginary because they come in pairs unless it's 2 extra, right? Because if I add 1, I have to add what? 2. That's what I was getting at.
So you just increase the multiplicity.
Yes. Okay, so find the polynomial function with the given zeros. So I have x minus 5, right?
Yes.
was a little. Okay. And then I have x minus 3 plus 2i. But then I also have x minus what? 3 minus 2i. Because I have to have what?
Plus or minus.
Plus
2i.
or minus. I have to have that conjugate pair, yes?
Yes.
Okay, so I'm going to multiply this all out, but first, what am I going to do before I multiply the quantities? I'm going to do what inside of them?
Distribute the negative.
Distribute the negatives. So I have x minus 3 minus 2i and x minus 3 plus 2i.
Yeah.
Do I still have the conjugate pair there? Yeah? The leading number is the same sign, and the imaginary number, one's positive, one negative. And now you just what? Multiply it out? Okay, so math it. When you're done, should there be any eyes running around? No. I would totally suggest to do the imaginary numbers together first. Because then you will get rid of the eyes. If not, you're going to make yourself a big mess to play with.
I am a big
I know, but I try not to tell you.
show you a big man. Wonderful.
Do it, Watson.
Oops. Nope, don't.
It doesn't tell us what degree it has to be.
No, it doesn't. It just says, so if it doesn't tell you, you just make it whatever is there. Does that make sense?
Yeah.
Are you guys working while you're mumbling back there?
I am. I don't know about the other one.
What do you want? I don't know if I did this right. Nick, I am writing notes. You be quiet.
Writing range.
This is Nick.
Yes.
Would you combine negative 9 and positive 4? And make it negative 5?
I forgot my negative 9, didn't I?
Yeah, it would be negative 5.
Yeah.
Okay, so where did the negative 3x and like the minus 9 minus 6i come from?
When I distributed this into this.
Oh yeah, it would be positive 9.
Okay, just a second. Yes, it would be.
My bad. Oops.
No, it wouldn't. It'd be 13. No, it'd be 13 because that would be a positive 4.
As well. Yeah, my bad.
So I need to change my last. Just a second. I'll answer your question. I just got to fix this now, okay?
Like, there's like one in every
Oh.
section.
Anyway.
You can scan QR codes.
Okay. What is your question, Taylor?
So where'd you like get all the numbers underneath the x
You
squared
can
minus
see the
3x
exact
plus 2x?
same numbers that you just-
All these?
Yeah.
So you just show.
Okay. I distributed this in.
Oh, okay.
So that's where I get that one. And then I line them up the next row. And then I line them up the next row.
Okay.
Okay. So let me try this again and not screw it up.
It's plus 13?
Yes, because they're positive 9 and positive 4.
Plus 13.
Okay. Hopefully I did it right this time. I was getting there to check my work because it didn't quite look right to me. Okay. Now do we match? Yes. So I just got to take my time and do it, right? This one didn't tell me anything. They didn't tell me a certain degree. I came out with a third degree because I have 3 zeros, yes? But if they said fourth degree, I would increase my multiplicity of my 5 by 1, wouldn't I? Now, if they said fifth degree, could I increase these two if I wanted to? Yes, I could, but that would be gross probably. But once you multiplied it out and got this, you could just square it, couldn't you? So I wouldn't do the imaginary twice. But when they add different degrees, then you have zeros. You just increase multiplicities of whatever you want. Now, if they give you a 0, one of the zeros is 0. Increase that multiplicity because that makes it really easy to change, right? So don't actually do a number unless you have to. Questions? Adelaide, are you good? Yeah. Okay, you were still writing, so I was just asking. Yeah. Okay, find the polynomial function with the real coefficients. Go for it.
Trick question, no solution, it says real coefficients, but it's got 3i.
Yeah, but I want the polynomial, so you have to find the conjugate that goes with that to give you reals. Does it change it just because I threw a square root in there?
Yes.
No. Makes it a little more time consuming, but it does not change it.
Well, my time is very valuable. We're not wasted on these square roots.
I agree with Kayla.
Okay.
Would you still put x minus in front of that?
Yes, you would still.
Ed, could you shut up?
You doing writing?
No, it's not.
Ruffling paper.
Okay, shh.
Wouldn't it be 10x?
I dislike you.
Yes, it would be. I multiplied twice. Thank you.
Yeah.
I was doing my rule and not. Yeah. Because I've square root of 3 times the square root of 3 is 3. I squared. And then all the rest zeroed out. Square root of 3 times the square root of 3 is 3.
Okay, yeah.
Oh, I got done before you started.
Okay, you guys agree?
I agree.
I don't know.
Does it take a little bit of time?
Yeah, some.
Yes.
How do you get 4? I got 10.
Because this, you forgot to take the square root of 9.
3.
Yes.
Oh, wait.
You just squared it and forgot that you had the square root.
Yep.
Okay. So, always multiply these together, right? Your conjugate pairs? Because if you multiply those conjugate pairs, when I'm done, I get a polynomial with all real coefficients, and I'm good to go, right? And then I have a whole bunch. Who's using the box? Anybody using the boxes on here? Okay, so using the box. I'm basically using the box by doing this. Who's making a big old one long list?
Me.
Okay, I used to make a big old long list, and I had a freshman come up to me, and he's like, Mrs. Mick, I had a teacher show me this method, and he showed me. I'm like, you know what, in class I'm going to have you show everybody that. Because I don't like it when I do binomial, binomial, okay? I like it when I have a binomial times a trinomial, or especially trinomial times trinomial if I go to a quartic. Because when I made this big old long list, those of you who make it, do you get lost in your list sometimes? No. Nope? Awesome. Candria's perfect. I get lost in my list. If I do this, I don't tend to get lost in my list. Make sense? Okay, questions?
I'm still working.
You leave it there just for a second.
Yep.
4 grams of battery excited.
Yeah.
Wait.
No, it's just in my pocket.
I was just doing the math earlier.
Okay. So factoring a polynomial, we have done this. I'm just going to state it right now, okay? We have always known that we could factor difference of squares, but we can factor sum of squares if we throw a what behind it? An I. So we have x squared plus 1 is x minus 1 and x minus I and x plus I, because that would be negative I squared. Yes?
Yes.
And I squared is negative 1, and a negative 1 is a positive. So I also can do the same here. X squared minus 2. I can also, 2's a perfect square. Everything's a perfect square, guys. You just leave the square root.
Well, ain't that perfect?
Okay? So if I have x squared minus 2, I can factor it to x minus the square root of 2 and x plus the square root of 2. Do I have the conjugate pair there?
Yeah.
Yes. The conjugate pairs go for imaginary and irrational numbers. Okay? So if you ever saw x minus the square root of 2, what is also there? X plus the square root of 2. Always. Okay? If you started out like if it says real coefficients. Okay? So knowing that I can, because you've been told you couldn't factor the sum of squares. You've been told that this right here is a non-real solution. Well, yeah, we know it's a non-real solution. Actually, it's not. It's not non-real. This is a real solution. Sorry. We've been told that we couldn't factor those things, but can we factor those things? Yes. But we also could just set it equal to 0 and take the square root, and would I get the same zeros? Yes. Yes, Selena.
I don't know if this is a dumb question, but why, when you write it, are you doing the square root of 2 when it's just a regular 2?
Because when, let me write so people can see this. If anyone ever does watch it. When I solve this, it would be x squared equals 2, yes? And so I'd have to take the what?
Okay.
Square root. So you have x equals plus or minus the square root of 2. So those are the zeros, but the factors are like that.
And so would you do that on like all of them, basically?
Like anything, like if I had x squared minus 10. Actually, let's give you 20. X squared minus 20. Okay, so x squared minus 20, we would have x minus the square root of 20 and x plus the square root of 20. But what's special about the square root of 20, guys? Is there a perfect square in it?
Yes.
Right? So x minus 2 square root of 5. and x
Plus.
plus 2 square root of 5. So we can do, yeah, please put that up.
That sound.
Yeah, that was horrible. So what it's saying is I can factor things I didn't even know I could factor. Okay? Because we don't start off by telling you you can do all these factors because your brain would go, like, kind of explodes anyway, right?
My brain is currently exploding.
Okay, find the polynomial function, finding the polynomial function. Okay, so it says find all the zeros. It didn't say rational, it didn't say real, correct? It says find all the zeros of x cubed minus x squared plus 25x minus 25. Is it in order?
Yeah.
Yes.
Okay. Given that 5i is a 0.
Would you plug in 5i?
Well, you can't plug in 5i. We could do synthetic division by 5i, correct? Or, okay, if we know 5i, they gave me 5i. They just tell me it is. Okay? If I know 5i is, what do I also know? Negative 5i. So there's two things we could do. We could take x minus 5i and x plus 5i. We could multiply it out and get x squared plus 25. Wouldn't that be the sum of squares? Yes? And we could use long division and find the rest of the zeros, couldn't we?
Yes. Yeah.
Or we could do synthetic division with 5i and negative 5i. Guess what we're going to do?
Synthetic division.
Both.
Oh.
Can we just
Okay,
for this one too?
so first we're going to do long division. Okay? So what do I have to do with this to be able to divide by it? No.
That's for the synthetic. Oh, fill the gaps.
Fill the gaps. We're doing long division first. Actually, I should have done synthetic division first, but that's okay. Okay, so do it.
Joe.
Shouldn't be that hard to do.
Oh my gosh, I thoroughly could have.
You mistyped those in it.
Just
Impossible.
If he's like, if
Yep.
Okay, did you get x minus 1?
I'm going to.
You're going to?
I will when I'm done with mine.
Okay, did it take me long to do that?
No.
No. And I got my zeros as plus or minus 5i and 1. Where'd I get 1 from?
What you do, you set your quotient equals 0.
Good job using that word. Using the quotient word. I set my quotient equal to 0, don't I?
Thicker.
Okay, so now we're going to do synthetic division. You ready?
Where's my sticker?
Where's your sticker? Right there. Okay, we're going to start with 5i. So 5i. And 1, negative 1, 25, negative 25. Oh, leave yourself some room. Don't put these close together. You need to give your I'm going to tell you. Because I didn't tell you to do it on your own, did I?
No, you didn't.
Okay. So we have to remember when we add and subtract imaginary numbers, we can only add or subtract like terms, correct? So are we going to have some quantities maybe?
Well, your like terms.
Okay, just,
The 25.
so bring down a 1. and we got 5i. Can I combine negative 1 and 5i? No. So I get the quantity of negative 1 plus 5i. So then I have to distribute 5i over the quantity. So that gives me negative 5i. And that would be negative 25i squared.
Plus 25.
So I get plus 25.
This seems a bit uncalled for.
Okay. So I get negative 5i
Plus 50.
plus 50.
Wait, if you did if 5i times 5i, wouldn't it be 25i squared? So wouldn't that be negative?
Oh, yes, it would be, yes. I put a negative in, it wouldn't because this is positive. Yes, thank you very much. Okay, let me say what she said. This is positive 5i, yes?
Yeah.
Oh.
Okay, so positive 5i times negative 5i would be negative 25? Well, no, it'd be negative 25i squared, and I squared's negative 1,
So it would just be plus 5.
and negative 25i squared. What? Oh, I'm multiplying by the wrong, that's what I did. This times this.
You're doing the wrong
I was doing this one, that's why. Thank you. So we have this, so I come out with negative 25.
Oh, yeah, no.
Okay, so then I just get 5i, negative 5i. And now I get my negative 25i squared, which is just what? 25, so I get 0. So that's a factor, yes? And it was supposed to, we knew it. So what's the other factor we know?
Negative 5i.
Negative 5i. Now this one should fall apart pretty easily, shouldn't it?
Hopefully.
Because we're supposed to have real solutions when we're done, aren't we? Okay, so negative 5i. So I bring down a 1, and I have negative 5i. Well, I'm left with what? Negative 1. Just negative 1.
Oh, yeah.
And then I have 5i, which I have what? 0. And don't I have x minus 1? Which would give me x equals plus or minus 5i and 1. Now, we did this, and it worked, yes? Was it very efficient?
No.
No. Was just multiplying the two out and doing long division the actually most efficient way?
Yes.
Yes. Synthetic division is not always the most efficient way. I have people every year, they're like, I'm going to do synthetic division no matter what. I'm like, okay, why don't you just multiply them together and get real numbers and do long division? Because remember, we can't do long division unless my x is a first degree, correct? And so I have x squared plus 25, so I have to do long. I can't do synthetic. But my long division was very short, wasn't it? Now, it could be a little longer. We started with a cubic and was dividing it by a squared, so it would only be one step. But it could be more. I mean, actually, one step with an x. But to me, when I do these problems, I always use this method. Because then I don't have to make the mistake of trying to multiply by my answer or not what I should have been multiplying it by. Because mathematicians, I always tell you guys, are efficiently lazy. To me, this is not efficient. I'm being lazy, but it's not efficient because I'm having to take more time to keep my brain straight. Make sense what I'm trying to say? Do I care which method you use? Nope. Do it right.
The synthetic is confusing but easy at the same time.
Yeah, it's not hard. You just got to keep your brain straight where you are because it falls apart fairly easily. The only thing where it might be more difficult is like this is x squared, and if I started off with like x to the 7th, because you would have those quantities more. You'd have more of the quantities. Okay, let's see what's next. That might be it. Okay, now it says find all the zeros by writing your polynomial as a product of linear factors and listing the zeros. Guys, that's exactly what we've been doing. We've been finding all the factors, yes? And then we've been finding all the zeros? Okay, so we have we have x to the 5th plus 3, x to the 5th plus x cubed plus 2x squared minus 12x plus 8. Yes? So, I don't know how to factor x to the 5th. Do you?
No.
Nope. So I need to do what? I heard somebody.
PRGs.
PRZs.
Fill the gap first. Like it.
Yeah, we're going to fill the gap, but we need our PRZs. And before we can do our PRZs, are they in order? Yes. Okay, there are a couple gaps. There's only one and a big space right here for some odd reason. So the factors of 8 are
2, 4, and 8.
okay, over the factors of 1. So do we need to write them over the factors of 1? Yes, Elena.
I know you probably where this one's gone. What's a PRZ?
Possible rational zeros. It's the factors of the constant over the factors of the leading coefficient. So things to choose from, to try. And yes, that was yesterday's video.
Why did you not scream at her to watch the video?
I already did. Okay, so what do you guys want to try? Oh wait, first we got to write it and we got to put in a what? 0.
Fill the gap.
Fill the gap. No gap teeth. Okay, what do you guys want to try?
0, 2.
Well, 0 wasn't an option.
2.
2?
Ethan already knows.
So 1, 2. Evan said 2, I think, first.
It's not gonna work.
-2.
Am I getting too big?
Yes.
Yep. So I'm not even going to finish. Just going back and put a negative, right? So that'd be -2. So -2. So still 4. So 5. But -10. That might help me out, right? So -8. So 16. So 4. Okay. When the majority are negative, we probably need to be putting in a negative, don't we?
Yeah.
Because we need to bring our numbers down at some point.
You mean majority are positive or what?
Yeah.
Okay.
Did I say negative? Sorry. Okay. So we started with a 5th, and we're now down to a what? 4th. And we still don't know how to factor a 4th, but my constant is what? No. My constant is 4. My leading coefficient is 1, so I can get rid of 8.
Yeah.
Correct?
Yeah.
Because 8 is not a factor of 4.
Oh, okay. Never mind.
Okay? And we're going to do repeated. Do not start over. Every time I get people starting over. Well, if you start over, are you doing yourself any good? No.
I started over on the last one.
Now, there's nothing to say that -2 is not another 0, yes? But if 2 wasn't the first time, is it going to be the second time? No.
But it is though.
No. +2 is not. If we couldn't get it to work the first time, it doesn't. Okay, listen. Is 2 a factor of 15?
No.
No. So when I factor of 15, is 2 going to be a factor of 3 or 5? No. So if 2 is not a factor of the first one, 2 is not a factor of the second one. So either we did the first one wrong or you did the second one wrong. Go back and check your math. Okay. What do you guys want to try?
1.
1 or 4?
Not 4.
Not 4?
It's gonna be
Kendra already tried. So I got 1, 1, -1, -1, 4, 4, -4, -4.
What was that noise for?
I don't know. I did it wrong. Okay, hold on. Wait.
I've
5 and
convinced
2.
myself.
Okay, 1. 2 and 1, 2. -2 and 2, 0. 2 and 0, 0. 5 and 0, 5. 2 and 5, 10. -8, 2. 2 and 2, 4. Oh, wait, that'd be 8. Yeah.
Okay. Now, again, guys, if 2 didn't work the first time, can we bring it back later on?
No.
No.
I thought.
Okay.
I saw a negative in front of the 4.
Yep, that's okay. So now we started with a 5th, we had a 4th, we now have a 3rd. We can factor by grouping.
Yes, let's do that.
You want to try that? Okay.
No.
We'll do it off to the side, so if we can't group, we have to come back, correct? So we have x to the 3rd minus x squared plus 4x minus 4. We group in the first 2, second 2?
Yeah.
Okay. So then x squared and x minus 1 plus 4 and x minus 1. So I have x squared plus 4 and x minus 1. Now it says list the factors first, yes? Okay, so this was what factor? What is -2? What factor?
0, 0.
No. What factor? X plus 2. What factor for 1? X minus 1. Are these linear factors?
The last three are.
The last three are, the first one is not. So we need to factor a sum of squares. What do we need to add in there?
X plus 2, X minus 2.
I, because it's positive.
Oh.
So I have X minus 2I and X plus 2I, X minus 1, X plus 2, and X minus 1. Do I have linear factors now? Okay, I have linear factors. Then what did it tell me?
I don't know.
Listing the zeros. Did it say real zeros?
No.
Nope, it says all the zeros, right?
Yeah.
So X equals, I go reals and then put imaginaries. So what? We got negative 2.
Yeah.
We have negative 1 twice. We need to know that if we were going to graph it, right?
It'd be positive.
Oh, yes, it would be positive 1. Positive 1 twice. So we need to know that if I asked you to graph because it would bounce there, right?
Yep.
And then plus or minus 2i.
So if that was an x squared minus 4, then,
Yes, I wouldn't be there.
but since it's plus, then it